Welcome back to another episode of Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I want to remind our listeners that if you're enjoying our show, please rate us on your favorite podcast platform. It really helps us reach more developers like you.
Thanks, Sheila. And hello, everyone. We're excited to continue our journey through Chapter 1, Understanding Decentralization. Today, we're focusing on a fascinating subtopic, logical decentralization.
That's right, Victor. And to kick things off, I've got a brain teaser for our listeners. Here's the question. Which of these is an example of a logically decentralized system? A. A company with offices in different countries. B. A blockchain network. Or C. A distributed database with a single control point. Take a moment to think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a good one, Sheila. It really makes you think about what logical decentralization actually means. I'm sure our listeners are already pondering the differences between these options.
Indeed. Now, before we dive deeper, Victor, could you give us a quick refresher on what we've covered so far about decentralization?
Certainly. We've explored the concept of decentralization in general, its key characteristics, and we've touched on architectural and political decentralization. Architectural decentralization refers to how many physical computers a system has and how they're set up, while political decentralization is about who controls these computers or nodes.
Great summary. So let's turn our attention to logical decentralization. Victor, how would you define this concept?
Logical decentralization is about how the system appears from a high level, particularly in terms of its data and functionality. A logically decentralized system behaves like a single, coherent system, even though it's made up of many parts. The key is that if you cut the system in half, including both the transaction history and the current state, both halves would continue to fully operate as independent units.
That's interesting. So, if I understand correctly, in a logically decentralized system, there's no central point that holds all the critical information or makes all the decisions. Is that right?
Exactly. You've got it, Sheila. In a logically decentralized system, the state and functionality are spread across all participants, and the system can operate even if parts of it are removed or isolated.
I think an analogy might help our listeners grasp this concept better. Victor, could we compare logical decentralization to something more familiar?
Great idea. Let's think of logical decentralization like a massive collaborative storytelling game. Imagine a group of people each writing parts of a story. No single person knows the entire story, but together they create a coherent narrative. If some storytellers leave, the story can still continue with the remaining participants. That's similar to how a logically decentralized system operates.
That's a fantastic analogy. It really helps visualize the concept. Now, could you give us some real-world examples of logically decentralized systems?
Certainly. The most prominent example is blockchain technology, like Bitcoin or Ethereum. These networks maintain a shared state, the ledger, across all participants, and no single node has complete control or information. Another example is distributed version control systems like Git, where the entire project history is distributed across all users.
Those are great examples. I'm curious, what are some of the advantages of logical decentralization?
The main advantages include increased resilience, as the system can continue to function even if parts of it fail or are attacked. It also promotes censorship resistance, as there's no single point of control that can be targeted. Additionally, logical decentralization often leads to better scalability, as the workload can be distributed across many participants.
Those sound like significant benefits, but I imagine there must be challenges too. What are some of the difficulties in implementing and maintaining logically decentralized systems?
You're absolutely right, Sheila. One of the biggest challenges is achieving consensus among all participants. Without a central authority, the system needs robust mechanisms to agree on the current state and resolve conflicts. This can lead to increased complexity and potential performance trade-offs. Also, ensuring consistency across all nodes can be tricky, especially in the face of network partitions or malicious actors.
That makes sense. It seems like there's always a trade-off between decentralization and efficiency. Victor, how do logically decentralized systems handle updates or changes to the system itself?
That's a great question, Sheila. In logically decentralized systems, updates often require consensus from a majority of participants. This can make the process slower compared to centralized systems, but it ensures that changes are agreed upon by the community. Some systems use mechanisms like hard forks or soft forks to implement significant changes.
Fascinating. Now, I think it's important to address a common misunderstanding. Some people might think that any distributed system is logically decentralized. Could you clarify the difference?
Absolutely, that's a crucial distinction. A distributed system isn't necessarily logically decentralized. For example, a distributed database with a single control point for schema changes would be architecturally decentralized, but logically centralized. True logical decentralization requires that the system's behavior emerges from the interactions of many independent participants, rather than being dictated by a central authority.
Thank you for clearing that up, Victor. As we wrap up, could you share a fun fact or interesting anecdote related to logical decentralization?
Sure, here's an interesting tidbit. The concept of logical decentralization isn't just limited to computer systems. It's also observed in nature. For instance, ant colonies exhibit logically decentralized behavior. No single ant, not even the queen, directs the entire colony. Instead, complex colony-wide behaviors emerge from simple interactions between individual ants.
That's fascinating, Victor. Nature never ceases to amaze me. Now, before we conclude, let's reveal the answer to our quiz question. The correct answer is B, a blockchain network. Blockchain networks are prime examples of logical decentralization, as they maintain a shared state across all participants without a central point of control.
Great question and explanation, Sheila. To summarize today's key points, logical decentralization is about how a system behaves as a whole, with functionality and data spread across all participants. It offers benefits like resilience and censorship resistance, but comes with challenges in consensus and consistency. Remember, not all distributed systems are logically decentralized.
Excellent summary, Victor. And that brings us to the end of today's episode. We hope this discussion has helped clarify the concept of logical decentralization for our listeners. If you enjoyed this episode, please don't forget to rate us on your podcast platform, visit crashcasts.com, or join our Discord community. Your support helps us continue creating content for developers like you. Until next time, happy coding.